We very much look at historical data, what's expected, what are the known changes, and how are they expected to affect the data. And if the data that we receive doesn't fall within those parameters, that's something that we immediately notice. But then there's another insidious problem where the data actually is fairly reasonable, but the distribution is wrong. So it's not just the actual individual values, and I'm sure this applies to clinical trials too. It's all data kind of thing, in that it might look good, the distribution may be odd, there may be holes, there may be areas that are skipped, and so while the average might be within range, the collection or the raw data is odd.
Welcome to the Information Week Podcast. I'm your host, Senior Editor Jean-Pierre Ruth. In today's episode, we are talking about stress testing and pressure testing data that might be a bit too good. There could be instances where everything seems to be falling in place with data that the organization is using, and it might be a little too perfect. So there might be some additional kicking of tires that might need to be done to understand what is actually happening with data and to really kind of get under the hood of what an organization might need to do to see what is the best way to handle, if not remediate, how the data is being used. So for today's conversation, we are joined by Grant Veazey, who is a CTO for Ensemble. Grant, good to be seeing you.
Nice to be on the podcast. Thank you for having me.
And we're also joined by Sebastien Jean, CTO for Phison Electronics. Sebastien, thank you so much for joining us.
Hi, everyone. Pleasure to be here. It's going to be interesting.
Great. Okay. All right, gentlemen. So let's talk about how you go about vetting, pressure testing, stress testing, the validity of data that could seem to be a little bit too good. Let's first talk about, for each of you, what's the type of data that your organizations work with, without giving away, state secrets in terms of what that data is. Are each of you working with complex data sources? What does that, look like for each of you?
Yeah, I'll be glad to start. Ensemble, we're in the healthcare space, so we're quite known for the opposite, our data being very bad, not too much being known for it being very good. So we deal from everything from provider data and standard formats, X12, HL7, interoperability with payer data. We still get lots of EMR data, whether that's streaming pipelines or batch. So a very complex amount of data that we have to deal with across the spectrum. So a lot of complexities in a lot of places where the data can be very bad. And as you said, very places we have to make sure we don't over-normalize and make sure that the data gets too good. So we got to keep that signal with that raw data, even though it's complex and messy at times.
Sebastien, what's your experience with that?
Yeah, so Phison Electronics, we make SSDs we make about 20% of the SSDs on the planet. There are about 5 companies that do that. And so our data is very different. On the one hand, it can, be very clean. It can be even unusually good, but we generally have a sense of where that data should be. And say, for example, and obviously if it's bad, like, the power of the device is well beyond the specification of what the industry will accept, that's an obvious red flag. The flip side is if it was too good, if we know the power should be 5 watts and we're getting 3.2, that's impossible. It's just, it would be like a tricycle that can go at 90 miles an hour. It's just impossible. And so that is an indication that we need to go back and look at the data and say, why is that? And it could be other ways, like it could be that the test equipment isn't right, or there's a miscalibration or a probe has gone bad. So for us, we're always very, very focused on understanding the data that we get and also determining if we have confidence in that data.
Gotcha. Well, speaking about getting into that confidence of the data, how you go about prioritizing the data, the testing process for the data. Are you looking at things like boundary value analysis, integrity audits? What do you prioritize individually?
Yeah, for us in the healthcare space, it's all about clinical safety first, financial integrity second, and just auditability, traceability, observability for that third piece. So, in the standard formats of things that are coming in FHIR or HL7, we're looking for, message integrity. Did things get lost? You're looking for, like I said, for over normalization of mapping. we're looking for those pieces and parts. On the clinical side, we're absolutely looking at some of the things that Sebastien talked about, right? That certain lab values aren't way out of spectrum that we'd expect. From a pure administrative data perspective, we're always looking at previous historical benchmarks. We're looking at what would happen from the perspective of a denial rate or a clean claim pass rate. We're looking at all those things, and we embed those in our pipeline, but then we're also looking at them and monitor them all the way through to analytics and AI models.
Sebastien, how about for you? What's the order of priority when it comes to doing the stress testing on data?
A large part of it is the same. We very much look at historical data, what's expected, what are the known changes, and how are they expected to affect the data. And if the data that we receive doesn't fall within those parameters, that's something that we immediately notice. But then there's another insidious problem where the data actually is fairly reasonable, but the distribution is wrong. So it's not just the actual individual values, and I'm sure this applies to clinical trials too. It's all data kind of thing, in that it might look good, the distribution may be odd, there may be holes, there may be areas that are skipped, and so while the average might be within range, the collection or the raw data is odd. And so with experience in your industry, you can kind of say, hey, this is normal distribution. And I don't mean normal in statistical sense, but this is a distribution that is expected versus this is really odd and I've never seen it before, even though the touch point values, the averages, the standard deviations and all that stuff might be okay. So there's a lot of intuition that goes into processing this data. And yes, that intuition can drive statistical tests and things like that so that, you can automate the whole process. That's doable. But before you can really understand you have to understand the data and the patterns it should follow, and then use that information to build different kinds of tests, either procedural with if then else kind of functional statements, or to build some kind of agentic solution where even then you have to be able to describe what is a good pattern and what is a bad pattern.
Trying to suss out those patterns, how useful is it for either of you to make use of simulations that make use of broken data? I mean, you've already got the potential for, Grant, you were talking about, there might be already messy data that's in there. How useful is it for you to make use of a broken data to see what shakes out further?
Yeah, we spend a lot of time trying to curate a golden data set because we want to understand what really good looks like and be able to run our models against that. And so it's on a daily basis of us trying to look at those message types, again, on the FHIR, the HL7, to make sure there's not missing pieces of that. We also want to go the absolute other direction as you're describing. So we want to throw some things outside of that golden data set. We want to see how the system will react. How do we look at that? How does it handle things that are outside of range? So we do not only simulations on a continuous basis of our data pipelines as we bring data in. As we do new release of products or models, we try to do some kind of what I would consider chaos testing against that as well, and really throw things right outside of the realm of that golden data set and really see how the system can handle that. Or, are there certain alerts that we want to have on a daily basis that are flagging things that throw us outside of the same thing Sebastien would say, outside of that range of what we know is statistically probability within that data set.
Gotcha. Sebastien, how about you when it comes to looking at making use of broken data and simulations?
Yeah. When it comes to SSDs, which is bulk storage, having SSDs that work 99.9% of the time is kind of like brakes on a car that work 99.9% of the time. It's great, but you really want that to trend towards more nines. You want that failure to be 1 in a billion, not 1 in 100 kind of thing. 100 times you break, the 100th time, sorry, that's a problem. And the same thing applies to these data. Now, on the one hand, you can go, storage boring. But on the other hand, you can think, storage boring, but it does have the balance of my bank account, and I would really love it not to become a negative number. So there are certain types of things which have a bigger impact and a smaller impact. But when it comes to an SSD design, one of the tricky parts is designing a system that has graceful degradation, detectable failure modes, and and can have not just graceful degradation, technical failure modes, but also a fail-safe design, particularly for like medical data, things that go into cars and stuff like that. And fail-safe means that if it just goes down the super improbable failure tree, right? If this fails and this fails and this fails, and you go, what are the odds of that? It will happen when you sell millions and millions of drives. So at that point, when it goes down that failure path, it has to either still be detectable or go into a mode where it is non-damaging to the operation. And so, for example, you don't return bad data, you just return no data. That is better than confidently saying, here's not the data that you asked for, but trust me, it's totally good. That your software usually doesn't work well with that. But so to that end, we actually spent a lot of effort creating an emulation system for our drives. So an SSD, a storage device, has a controller, it has RAM, and then it has non-volatile memory, which for an SSD is technology called NAND. And so NAND flash memory, it is very, very hard to test all of the failure modes within the drive if you're trying to find, we also use the term golden drive, but the golden drive in this case is a golden failure drive that has the worst case failure pattern. So in order to test our software that runs on the embedded system and the controller and all the error correction paths and everything else, we actually built a NAND which is the non-volatile media. We built a media emulator which uses the same protocols, and we actually have these low impedance cables that we connect to a PC, which now we're using a very powerful computer to emulate an analog memory. Well, it's digital. There are analog components to it, but we're to emulate a memory device. And with that, we can program any bit pattern, any failure mode, and randomize it such that we can actually exercise the real firmware, the real hardware, the real PCB in a way where we have absolute control over the data. And then we can feed in both known failure modes based on all of our data collection, as well as really unlikely, really weird failure modes. We can also feed those in, and that allows us to mature our product much, much faster. So negative testing with broken data is actually a very important part to building resilient systems.
With the, how model visualization and scenario testing works, are there other methods that you're looking at that might have a potentially better ROI versus the time and effort that might go into those methods?
I mean, for us, again, being able to trust the accuracy of our data, not only from a clinical perspective, but a financial accuracy perspective, the ROI is tremendous on visualization. So we start with, precision and recall, but our ability to be able to see that kind of predictability shift through the entire lineage of our data. We're trying to put together a patient journey from start to finish of what it looks like from the patient encounter all the way through. We need to be able to have that traceability and understand the kind of the model precision and recall, what we do all the way through that evolution. So it's really important for us to use those visualizations, whether it be on performance, whether it be on stress testing, whether it be on our sensitivity analysis of what we would do on a clinical coding recommendation that we may make. It's really important for us to be able to have that visualization for the experts who aren't experts in the data to really be able to understand that and be able to understand the impact of the data we're providing and build that trust for us, and specifically in healthcare and what we do for our provider and health system clients. That trust is immense. So it's the return on investment is huge, because if they don't trust what we do, our services, our product is really not valued.
Sebastien, I see you nodding along. Your input on that, please.
Sure. So, you were touching on the ROI, and I can address both what I was mentioning before, along with what Greg said. So, the emulator was actually a really complicated task to develop, and it took a lot of engineering effort. We actually, because we had to design custom cards and a whole bunch of things to actually make it work at full speed and look exactly like the real thing. But the reason we did that is because it allows us to get to market substantially faster. We can typically go to market roughly 2 months faster, assuming two similar products using our own technology, with and without the emulator, our time to market is roughly 2 to 3 months faster kind of thing, which means 1 quarter. And of course, there can always be delays in the development pipeline, the validation, and everything else. And so having something that can naturally finish faster gives you a little bit of headspace to kind of meet those market deadlines. Now, this is obviously very different from healthcare, but what we got to this point because we found that it actually was really actually valuable to the company. We get to market faster and generate revenue faster to compensate for all of the capital expenditure and the operational expenditure of actually developing this new product. But when it comes to, and so that's the ROI on just having the system. But when it comes to the ROI on visualization, here too, this is where there's a similarity between both industries, because the ability of our brains to detect patterns that that we've never seen before, pattern matching is something that humans do really, really well. And sure, you can make a machine that will detect unusual patterns, but that's always based on a foundation of the experience and the observations that we've had. So there is a huge value proposition in collecting the data, putting the effort to have dashboards that can be manipulated without affecting the data. That allows multiple people to look at the information and come to reasonable conclusions. Or sometimes people who make the decisions are not necessarily subject matter experts, but their focus is on risk mitigation. And so with those people, they don't need to understand all the nitty-gritty inner workings. The data just has to be presented in a way that it can be interpreted by reasonable people. And so there's a lot of value both in machine emulation, but also in visualization to support just basic understanding.
Speaking of reasonable people and reasonable ideas and risk mitigation, I've picked up the Ninja Turtles game stream, which now means it is time for Questionable Ideas, our tabletop exercise where our panelists will step in as interim executives with the fictional company known as Questionable Ideas. These scenarios, which may or may not be over the top, will relate to today's topic. The panelists have not seen these scenarios in advance, and they are not responsible for the presence of goblins, gremlins, or kobolds in these scenarios. That is entirely my fault. And just lay out the ground rules again. With this, both Sebastien and Grant will have the same rights and privileges that they have within their organizations and whatever additional resources they may need to call in to address the scenarios that are being presented to them. The goblins represent the fast-moving, let's just do things as quickly as possible. This seems like a shiny new bit of technology. Let's plug it in kind of ideas. The kobolds represent more stoic, staid kind of approach to technology. And the gremlins are, well, they're just chaos. They say, why not break things and see how things work afterwards or not? So again, since both of you are CTOs, you will be co-CTOs, interim co-CTOs for Questionable Ideas. Grant, Sebastien, are you ready?
We're ready.
Okay, great. All right, first scenario. Questionable Ideas is undergoing a migration to a new environment with all the cloud, AI, digital resources you could ask for. The goblins handled the stress test of the applications under their go very fast principles. Workloads seem to scale properly and latency is low until a few weeks pass and reconciliation jobs fail. There are conflict reports from downstream analytics and query performances are imploding. The goblins promise the data is clean, but it turns out they only used recently standardized data and issues arose when legacy data was accessed. How do you resolve this? The goblins claim the legacy data won't matter because the company is forward-looking.
Yeah, I can definitely start. Definitely cannot just use the standardized data from that perspective. So we're going to have to go back and either take a sample of the legacy data or take the legacy data itself in a parallel system and run that through those data integrity pipelines and have the proper checks in place to see, again, if there's any type of message degradation, any type of ETL issues as we bring that through and stress and pressure test that in the actual production system in a lower environment to see what the real issues, almost kind of start from scratch from that testing process and make sure that if we didn't test it with the legacy data or a sampling of that legacy data, then a very high probability that we're going to see some issues downstream in production analytic systems.
I mean, the goblins promise that everything's going to be moving forward and they're only looking to the future. Sebastien, what are your thoughts on how to address this additionally?
There's the immediate problem of dealing with data and reports and reconciliation that doesn't work. And then there's, which can be addressed, as Greg pointed out. And then there's the operational or the organizational problem where a group responsible for a key function did not have the proper outlook when it came to mitigating risk. And so this is an opportunity where you have a conversation, you explain what your expectations are, what the priority is. And hopefully it's just a conversation where you reset the baseline and then you kind of move forward from there with a new understanding. Now, if you're actually dealing in a scenario where people are, like just really total goblin mode, where they're like, no, we're young and crazy, we want to go fast, fast, fast. It's like, you haven't had enough lawsuits yet. So you will quickly learn to see things differently after some pain. But that being said, the CTO's job, is to protect the organization, particularly from the highly motivated, highly intelligent, people that just are go-getters and they're crazy. It's not that they're bad. It's that, the organization needs both the goblins and the kobolds to kind of counterbalance each other. And you should actually have processes in place that essentially require executive overview to actually just basically say, hey, this is a supercritical system. For example, it's medical data, lives are at risk. We have a standard way of doing things. The FDA has certain requirements and things like that. But I want you to present your plan to me. And it's not necessarily that I am the best person I'm not necessarily the subject matter expert on that particular thing. But if they cannot explain it in such a way that actually it makes sense, because one of the things that people, and Greg and my own role, one of our jobs is pattern recognition, looking for human behavior and things like that, overconfidence. And we will actually I want to hear them explain the idea to me. I want to hear the thought process. I can tell when the thought process is errant or has gaps. And I want to go through that whole flow by having those checkpoints in your process after you've dealt with the immediate data. What you end up doing is instilling this mentality within the organization that people care. It's important that you take things seriously, and you won't necessarily be rewarded just by finishing fast. You also have to finish at the expected quality level.
Well, the goblins will definitely require some training to understand, quality over moving fast, since that is, in their blood.
Maybe some compliance training as well.
Yes. Well, compliance is another issue with them because they allegedly may or not have kidnapped the CFO a couple of episodes ago. Yeah. Okay, great. All right, scenario 2. The security team at Questionable Ideas comes to both of you with a red alert. They have caught a series of fraud attempts by an outside bad actor. The problem is the fraud detection system should have spotted this in theory. It was designed and tested by the kobolds for this very purpose. Upon closer inspection, it seems the kobolds used highly sanitized synthetic data that they call the pristine garden, and based on very dated data samples. And the fraud detection system was very successful in testing, largely because of that predictability. How do you recalibrate this testing process going forward?
Sure. Start with that one as well. Obviously, the first step we're going to go through is make sure that we've remediated and stopped the fraud attempt. But you're talking about the testing procedures from that perspective. So again, I think it's a perfect example of what you've got of having your data is too good or looking at your golden data set from that perspective. So it's sitting back and looking at, how do they penetrate? What are all the out of bounds scenarios that we need to look at from that perspective? How do we bring all of the data aspects back into that testing plan? It's a lot what Sebastien talked about as well, sitting down and kind of reviewing that plan from end to end, even though you're not maybe the subject matter expert, looking at it through that lens of what's the logical outsider view that you could put on this as well. What was the logic that the fraudster used that we didn't use, right? That's one of the things. What were our blind spots? How do we look at it from we maybe are too much of a subject matter expert and someone who looks at it from an outside view from that perspective. And you can look at your entire security program that way, as well as your data aspects of it, to look at it to say, how do we look at this from a different perspective, and what perspective do they use? to introduce that? How do I take those lessons learned, bring them back in that same type of cultural mentality to kind of build those scenario tests out, the data sets that we use to do those scenario testing to make sure that our fraud detection is truly where it needs to be from that perspective. And it's instilling as well kind of a continuous process of that. So whatever falls out, that you're kind of learning from those and building those back into your testing scenarios. Because the one thing that we know specifically from our seat in the healthcare space is that there is always a new avenue to find a different way around the existing processes and procedures. So how are you testing for future-proofing those against fraudulent behavior?
Sebastien, your thoughts on the pristine garden approach that the Cobalts had introduced?
That is not good. Because there's a type of person, really smart people that like solving puzzles. They get their whole goal in life, because they see the security system, right, as a challenge. It's like, okay, this is a system that was deliberately built to thwart me. I wonder if I can be the smarter bear and break through anyways. And, sometimes it's just the thrill of breaking through. Sometimes they're trying to get money kind of thing, like a reimbursement system. And so if you go with, given that their mentality is the exact opposite of a rule follower, testing your system with data that follows the rules basically accomplishes something. It does functional testing, but it certainly doesn't do security testing. And so when you approach testing, because oddly enough, people actually try to attack SSDs to force them to run code that is not appropriate, or to do inappropriate things with data, or to bypass security protocols and things like that. So, and these people are the kind of people that will spend months. An employee will not spend months on a problem because they have a schedule, a deadline, and things like that, right? So it is really beneficial, particularly if your data's or your system, whatever it is highly sensitive, to actually have a team whose whole purpose is to try to break in. And so, and not any, you can't just assign any random engineer to this. You have to assign people that have a predisposition to just getting a kick out of messing things up kind of thing. And so the more aggressive you test your system, both with basic positive and negative testing and out of bounds testing, but you should also do a type of testing which is called fuzz testing. And so when you're fuzzing, what you're basically doing is not only are you not following the rules, but you're not following the protocol rules, and you're like setting bits incorrectly. You're doing things in an odd order. You try to do them quickly, or potentially you try to do them after some, timeout thing has tried to log you out. Maybe that mechanism only kind of logs you out, but you still have access to some pages. So by going through the positive, the negative, the white box, the black box, and the randomized fuzz testing, you can, that is a methodology that can allow you to explore through automation a wide range of scenarios. But then having a team of people who are intelligent and motivated to have experience in breaking things actually attack it in a methodical way that they know other systems sometimes fail, can be very beneficial. So everything costs money, everything costs time, but sometimes it's justified given the nature of the industry, and sometimes not so much, right? And this becomes also a business decision.
Breaking things is definitely part of this last scenario, because the gremlins have stepped up and it's their turn to mess with things. The gremlins have come to you when they say that the problem with the company's data stress testing is that it's just not done with really hard challenges. They say it is time to actively push corrupted historical and training data that includes process bias, undocumented manual overrides, and incomplete event histories into this system. They want to unleash what they are calling the Pompeii protocol, which would crater the data integrity across the company in the process and require an extensive rebuild. But it would expose issues, at least as far as they are seeing it. Do you let the gremlins unleash Pompeii in a very unsystematic way?
Yeah, absolutely not. Certainly not in your production systems. I think, perfect example for us to create a sandbox environment, a replication of that environment. I think there's some very credible aspects to what they may be proposing that could be actually very useful. But let's do them in a more contained, safe environment, away from production disruption, of what that could have on the effect of our customers, our patients. Again, in our world, these are actually life-changing events that we're doing. So we've got to be extremely careful. We're highly regulated. We've got to stay within those boundaries. But there could be a lot of very interesting things. What we talked about on the previous conversation of really using this as a place to kind of test the limits. But let's do it in a safe environment. Let's do it in a replicated environment. Let's do it in a way that we can also monitor those results, bring those results back in so that we can understand how to then kind of migrate those to a production environment. But absolutely, let's do it in a safe, protected environment.
Sebastien, your input on how to deal with the gremlins in their Pompeii protocol.
Yeah, the concept is very good. But this is where, the organizational aspect comes in. To Greg's point, you do not test a live system. Now, here's the trouble, because we're all human, right? And let's say that we're friends with one of the gremlins. We just get along naturally, right? So their words are going to have more sway on us, potentially. And so, and they're going to, this guy or girl, this person is very, very persuasive, great speaker. And this individual has the speech and says, what could possibly be more realistic than the real environment? You can't get more real than real. And that's where you put your foot down and you say, no. Because at the end of the day, let's say that we do this and people die. You can't reset that. Or we do this and people lose a lot of money. Maybe their life savings gets wiped away, or their health insurance policy disappears. They're no longer in the system. That is completely unacceptable, and that could cause permanent reputational damage to the organization, to the point where you lose all your customers. You go out of business. It doesn't matter if you did the best test conceivable if you cannot continue operations to generate revenue to service your customers, but also to pay your employees, because everybody needs their paycheck. And so to that end, anyone who argues what could be more real than real maybe shouldn't be in a leadership position, because you can absolutely, at the end of the day, if I have two identical systems using two identical copies of the data, but one is processing live incoming customer interactions and the other one is using simulated interactions, and this is where you can use AI, test scripts, and a whole bunch of other stuff. But just because at the low level the server address is slightly different, but everything else is the same, to argue that that's not real enough is amateurish. Nobody with in a senior position would argue that. So let's say these gremlins are arguing that. Well, then in that scenario, you basically, again, have to be, the person who sanity checks their arguments. And then you don't have to necessarily lay down the law and, just command things like that, because it generally doesn't work really well with smart people that like to break rules. And so what you really say is, let's have a conversation. Let's say we do this and, and then we actually corrupt all of the data and 7 people die. What is your approach? You make them solve the problem, or at least think it through. Ultimately, what you want to do is get buy-in into what you're proposing, because buy-in is much, much more effective than mandates. With buy-in, people actively use their brains to align with the objective and the priorities of the organization. Whereas with commandment, you're basically telling them, don't think, do what I say. And now you better be really good about thinking about everything, because you've effectively discouraged your team from being creative. And that also doesn't have good outcomes.
Well, you definitely laid the groundwork for good outcomes with those very reasonable sanity checks laid out for the gremlins and also for the other elements of questionable ideas. All right. Well, Sebastien, Grant, thank you so much for coming on the podcast today. You have definitely shared some great insights and great guidelines for dealing with some, how to approach stress testing, and also some wacky ideas that might come up with people who think they're going to be helpful, but are actually potentially causing the damage. So I appreciate you both for coming on today.
Thank you for having us.
It's a pleasure, JP. Thank you so much.